Unraveling the Past, the Magic of Radiocarbon Dating. Hello, everyone. Today, we're diving into an intriguing topic that connects us with the history of our planet, radiocarbon dating. This method has revolutionized the way we understand the age of objects from the past. Whether you're a student, a history enthusiast, or just curious, stay tuned to uncover the secrets behind this fascinating technique. Radiocarbon dating is a scientific method used to determine the age of an object containing organic material by using the properties of radiocarbon, a radioactive isotope of carbon. It was developed in the late 1940s by a team led by American physical chemist Willard Libby, who later won the Nobel Prize for his work. The key principle behind radiocarbon dating is that living organisms absorb carbon, including carbon-14, from the atmosphere and food. Once the organism dies, it stops replenishing its carbon supply, and the carbon-14 begins to decay at a predictable rate. By measuring the amount of carbon-14 left in a sample, scientists can estimate the time of death, giving us a window into the past. To understand radiocarbon dating, we need to grasp two main concepts: half-life and carbon cycle. Half-life. This is the time it takes for half of the carbon-14 in a sample to decay. For carbon-14, the half-life is about 5,730 years. This means if you start with 1 gram of carbon-14, after 5,730 years, you'll have half a gram left. Carbon cycle. Carbon moves between the Earth, the atmosphere, the oceans, and living organisms in a cycle. Carbon-14 is formed in the upper atmosphere through the effect of cosmic ray neutrons on nitrogen-14 atoms. It is then absorbed by living organisms, and it decays back into nitrogen-14 after the organism dies. By measuring the remaining carbon-14 in a sample and comparing it to the expected amount in a living organism, scientists can calculate the sample's age within a certain range. Radiocarbon dating has been used to date objects as old as 50,000 years. Its applications are vast, from archaeology to geology, from studying climate change to solving historical puzzles. However, it has its limitations. It can only date materials that were once part of living organisms. The accuracy decreases for older samples. Contamination and environmental factors can affect the results. Despite these challenges, radiocarbon dating remains a powerful tool in our quest to understand the past. Radiocarbon dating is a window into the history of our world. It allows us to connect with the lives of people and organisms from thousands of years ago. We hope this video has illuminated how this incredible technique works and why it's so important in the field of science and history. Thank you for joining us on this journey through time. Remember, the past is the key to understanding our present and shaping our future.